Hello, everyone, and welcome to Restoring Rivers, Reconnecting Nature, the Becker Pond Dam Project. This is our final webinar in a series of 3 webinars over the last 5 years, providing information about the upcoming dam removal in Mount Washington, Mass. I'm your host, Karen Lombard, Director of Stewardship and Restoration for the Nature Conservancy in Massachusetts. And as we get started, just please note if you have questions, please put them in the Q&A rather than the chat. And we'll now get started. So as I mentioned, I'm Karen Lombard. I am based in Western Massachusetts and lead a stewardship team that manages the Nature Conservancy's 30 preserve in Massachusetts, including 10,000 acres of land, most of which is in the Berkshires. And half of that is in the Southern Berkshires, in Egremont, Sheffield, and Mount Washington. This work includes monitoring properties and ecological restoration to benefit many rare species. I have a Master of Science degree from the University of Michigan, where I studied natural resource management. But today we are here to talk about the removal of Becker Pond Dam. We've been working on this dam removal for 7 years and are very excited that we're about to start construction in November. And we want to share with you the details about the process and what will be happening at the site as the project gets underway. I would also like to offer a warm welcome to our guest, Chris Hirsch, the Dam Removal Program Manager for the Massachusetts Division of Ecological Restoration, also referred to as DER. And Chris earned a master's degree in restoration ecology from the University of Wisconsin, where he studied wetland recovery post-restoration. In his current role, he manages dam removal projects throughout the Commonwealth and supports a team of dam removal project managers, and also works to advance the practice of dam removal in Massachusetts. And as I mentioned, as you think of questions for Chris or myself, please enter them in the Q&A box. Now I'm going to share, I will start the presentation and before turning it over to Chris. So thanks so much for joining us today. So to start, the Nature Conservancy is a global nonprofit conservation organization with a mission to conserve the lands and waters on which all life depends. We are located in all 50 states and 81 countries, and we work on the dual crises of biodiversity loss and climate change. Dam removal is a key strategy for river resilience and health, and we are working on 400 projects in 40 countries. But today we're going to talk about the Becker Pond Dam removal. And it's Chris, next slide, please. So Becker Pond Dam is a relatively small dam that's located in Mount Washington in the southwest corner of Massachusetts. And you can see it's located in our Mount Plantain Preserve, which is 1,500 acres. We protected most of the land in this preserve about 25 years ago and came here because of the wonderful and large intact forested and wetland systems in this part of the state. And the Mount Plantain Preserve also provides important water source for the Chenal Brook Preserve, which you can also see on the map, which is our largest preserve in Massachusetts and protects a large number of rare species and globally rare wetland systems. So the Becker Pond Dam is located at the very southern end of the preserve, not too far from the Connecticut border, at the southern end of East Street. And it's a little bit hard to get to. It's down a very small woods road that starts on private property. It came with the preserve when we protected the property. It was probably built by the Dombrowski family, who we bought that particular tract from, and they built it in the 1930s, probably for recreation, ice skating, fishing, and swimming. It's located on an unnamed stream that does eventually flow into Chenal Brook, but goes through the iconic Sages Ravine, which has a lot of wonderful waterfalls and plunge pools and is well known locally. And the Appalachian Trail crosses Sages Ravine probably about a mile south of the dam. We were doing some routine monitoring of the preserve, as we do every year, in 2016, and we discovered that the dam was failing and could be a hazard. There was at that point kind of a wooden bridge that crossed the top of the dam, which was starting to shift. These are pictures of Sages Ravine. So yeah, here's a picture of the dam, which is just, it's like a concrete core with an earthen dam associated with it. And that shows a picture of the stream. And here shows the sidewall of the dam that was starting to fail, and then was causing the wooden structure you can see at the top of that slide to become unstable and unsafe. And that's where folks in the past had crossed the stream at that point. So at that point, we contracted with an engineering company to do an assessment of the dam, and that study found critical deficiencies in the dam and recommended removal, as it would be very difficult and expensive to fix the dam, and also from TNC's perspective, fixing dams is not really part of our mission. Restoring rivers and improving them for climate resilience is really a much better fit with our mission. We're very lucky early in the process, when we started the dam removal process, to partner with DER, and they have provided critical technical support and funding for this project, as has the Mass Environmental Trust. So very lucky to have them. And an outcome after the dam is removed, we're very excited to open a new trail in the area. It's going to be called the Hallig Trail, and we've already completed some sections of the trail. Here's the Greenagers Youth Corps that worked on some bridging over some wet areas, as well as building this wonderful bridge over part of the same stream upstream from where the dam removal is going to be. So we haven't been able to finish the dam because it's been a safety hazard. Finish the trail because it's been a safety hazard. And so we're really looking forward to doing that in the next year. So, and this map shows you the orange dotted line will be the location of the current trail, and we will connect it up to East Street once the dam is removed. So at this point, I'm going to turn things over to Chris for more details on how the dam will be removed and what to expect during and after construction. As we've mentioned above, Chris and DER support many dam removal projects in Massachusetts and provide technical support for landowners who may not have experience with dam removal. Thank you so much, Chris. So over to you.
Be unmuted.
Okay.
There we go. Sorry, I was muted for a minute. Thank you, Karen. So as Karen mentioned, TNC took over this ownership of this dam as part of a land acquisition. And like many dam owners in Massachusetts and elsewhere, they were met with the decision of what to do after finding out that their dam had deficiencies and needs major repairs. And so there was a decision-making process that went into, why we were removing this dam. And part of that is that the dam doesn't serve a practical purpose anymore. The dam is not providing electricity for TNC. It's not a drinking water reservoir or a water reservoir of any useful purpose. And so TNC really doesn't have a use for maintaining this dam. And as Karen mentioned, parts of the dam structure are failing currently, and that presents a safety hazard for anybody who's utilizing the area for recreation. And it presents a liability risk for the Nature Conservancy. And so through the engineering analysis, they looked at the costs of removing the dam versus the costs of owning and maintaining the dam. And it was more cost effective to remove the dam. And while all of those are sort of important reasons and considerations, if I can be as bold to speak, and Karen, please correct me if I'm wrong, I'd say the most important reason to TNC was really just being a good environmental steward, doing the right thing for the brook, restoring this area, and the health and function of it. And dams, as you may or may not be aware, are pretty harmful to riverine ecosystems. And so here's sort of a brief explanation of how dams harm rivers. So on the top, you can see sort of a natural river system. Rivers at their most core defining feature is that they are flowing water, essentially. And that flowing water brings about many different important functions like natural temperature regulation, which is very important for a cold water system like the one that we're working in here. A natural flushing of the sediments and maintaining the bed substrate that supports the food chain, the bottom of the food chain, the macroinvertebrates. It supports the critical habitats for fish and other aquatic organisms during their various life phases. And it's really important to have that water flowing through the system. It transports nutrients, it transports other types of structure like wood that are critical habitat for fish and other wildlife. And when you build a dam in a river, you disrupt that flow of water. You slow things down, and that results in finer sediments building up behind the dam, burying those substrates that would naturally be there in a riverine system. You're essentially slowing the water down such that it heats up in the sun. You're not getting the dissolved oxygen from the churning of the water. And you're blocking fish and other aquatic organisms from being able to move freely upstream and downstream, which can impact genetics. It can prevent fish and other organisms from getting to different areas that they need to utilize during different life stages, and it can be just really detrimental to the system as a whole. And so removing the dams restores that flow of water. And really the philosophy behind DER's approach to restoration and the approach that we took on this project is really about restoring those key critical functions that a riverine system has. So free flowing water, allowing organisms to move freely upstream and downstream, the critical lateral connections of the channel with the floodplain wetlands on either side, the natural flowing of and distribution of sediments and wood and other habitat forming materials, as well as natural thermoregulation, which again is really important for cold water systems like we're working in here. And in the context of global warming, cold water systems are at risk of being lost because of exacerbated heating during especially the summers. So really the approach we took here was restoring the functions, looking at what it is that makes a system healthy and making sure that those functions are restored and operating properly so that this system will be on the trajectory to heal, and the section will resemble what it looks like in this system upstream and downstream. And that's really the key of creating a sustainable, resilient system. And what that means for you and the public is, removing this dam was going to result in a safer recreational experience for those users who visit this site. And we're going to have a healthier river system as a whole, which will benefit the cold water species, benefit anyone who enjoys angling or other sort of water-based recreation. So now I'm going to switch gears a little bit and talk about the nuts and bolts of really how this project is going to work. So the Becker Pond Dam Removal Project really involves three key stages. There's establishing the access for construction. There's the actual meat of the project, the removal of the dam, and then post removal monitoring to ensure everything went as planned. As Karen mentioned, and as you saw on those maps, the site is pretty remote, and we need to be able to get machinery in there to do the work, which means we need to work out an access. There were two sort of alternatives that we explored for this project. The first involved utilizing a private property to access this logging road that you see in the photo that already exists. Unfortunately, TNC wasn't able to get an agreement to access their property, and so we're going with alternative two, which involves cutting a new logging road essentially from East Street down to this existing logging road so that we can access the site. And that, as Karen also mentioned, the plan is to use that new logging road as a walking trail afterwards. So it'll be brought in and narrowed to just a walking trail post project. So here's sort of a zoom in of the access. So this yellow line here is where we're going to be cutting the new road. There's also going to be an area near East Street that's cleared for construction staging, where so the construction firm is able to stage equipment and materials there as they conduct their work. This area is going to be selected in the field and verified in order to minimize the amount of disturbance. So we're really trying our best to not cut many trees, avoid tree cutting to the extent possible. I don't think it'll be possible to get through with no trees. It is a forest after all, but we're really trying to minimize that with the layout of this road. And all of the woody material that is harvested during the establishment of this road is going to be reused on site to create habitat features and floodplain complexities in the former impoundment. So once access is established, we'll really get into the heart of the project, which is the removal of the dam. And that's going to happen with 6 essential stages. So the first stage is what we call establishing water control. So the contractor will be building a cofferdam, a small temporary dam at the upstream end of the impoundment. And they'll use a pump and piping system to basically prevent water from entering the work site from upstream, but also maintain flow downstream throughout the construction process. Once that water control is established, the impoundment will be drawn down, either using a siphon or a pumping system, and that will dry out the area and make it ready for vehicles to enter. So at that point, the contractor is going to construct a pilot channel through those impounded sediments that have built up behind the dam. And that's really intended to reduce the amount of sediment that is released downstream, because there was concerns that sediment additions would impact recreational users down at the Sages Ravine area and some of the swimming holes there. So we're taking a very conservative approach there with sediment. Once the pilot channel is established, then the contractor will grade and stabilize those banks and move on to removing the dam's concrete core, laying back those slopes, stabilizing those slopes at the breach as well. Most of the excavated sediment will be reused on site. If there are excess sediments that need to go off site, they'll go off site to hopefully be reused in an approved context. Finally, once the work is completed, the construction staging and access areas will be restored to a walking trail. So the margins will be brought in. They'll be seeded and planted to reestablish vegetation along the sides and really open that up to walking trails. This project is about to kick off. And so we don't anticipate the plantings to actually occur until the spring after, because it doesn't make sense to plant in the winter when the ground is frozen. So some of the things that you should expect to see with the project, obviously there's going to be a new clearing along East Street where you'll see the staging area as well as the access road. There's going to be some impacts from the establishing the access road, so minimal tree clearing, mostly brush clearing, things like mountain laurel. Most dramatic at the site, and what I'll show you shortly, is the transition between sort of a pond habitat upstream of the dam to what will be a flowing stream with a mosaic of riparian floodplain wetlands and riparian uplands. And what you'll may or may not notice, but what we'll likely see, because we'll be monitoring the fish populations here, is a conversion of fish and aquatic community within the pond from a cool and warm water system to a cold water dominated system like you see upstream and downstream. So as they say, a picture is worth 1,000 words, or says 1,000 words. I wanted to show you all some examples of projects so that you can get a sense of how things change in the impoundments once dams are removed. So here's Weeki Peaky Brook in Lancaster, Massachusetts. This is immediately before the dam removal, so you can see obviously the dam's still there. There's an impoundment behind it, a pond. And here's immediately after the dam was removed. So you can see they've breached it. They've laid back the slopes so that it's stable and passes the appropriate sized storms. And you can also see the exposed impounded sediments and brand new channels forming through those and head cutting and eroding through those impounded sediments, which is really, a magical thing to watch for a river nerd like me, because you get to see a river reborn. It's really cool. But here's what it looks like after 3 months. And this is with no planting, no seeding, no intervention whatsoever. Those impounded sediments are full of nutrients. They are full of historic seed bank, native wetland plants that are just waiting for the chance to get a little bit of sunlight, a little bit of oxygen, and they just take off. And so this is what the site looked like after 3 months. And here it is after a year. And if you hadn't known the history of the site, you may walk by and not even know that there was a dam ever here. Also note that the beavers also identified this as a great place for a dam and have established their own dam, which I won't get into it and get on my soapbox now, but is actually encouraged. Beavers are incredibly important to our aquatic ecosystems. And then here's another example. So neither of these are exactly what you're going to see, because we are going to be doing some seeding within the impoundment, and we're also not going to allow the channel to form naturally on its own. We're going to be doing work. So what you'll see out there, if you were to, watch throughout construction, would be a sort of a mix of the previous example I just showed you and this example here, which is Amethyst Brook in Pelham. So here's the dam pre-removal. Here's sort of mid-removal as they're starting to chip away at the dam. You can see they've established water control through this outlet. They have water pumping through this channel here. And what you can't see is a cofferdam on the upstream end. So this whole area has been dried out so that they can actually construct the channel. Here you can see the constructed channel through. So this is sort of immediately after initial construction is wrapped up. At this site, there were erosion control blankets installed. There won't be erosion control blankets installed in the impoundment at our site. That area will just be seeded, sort of like this outside bend here. But there will be some erosion control blankets on the stockpile areas, just to make sure that those don't move. As you can also see, here's some floodplain roughening, so that there'll be similar log placements on the floodplain to really encourage hydraulic connection between the floodplain and the channel during flood stage. So this is what the site looked like sort of immediately after construction. And here it is after a couple of years. Again, the goal is to have a site where you wouldn't know that a dam was removed there. In this case, there was some historic aspects to the dam that we left some remnants of the dam in place to honor that, and there was some signage also installed to explain the history of the site. But without those sort of clues, you may or may not recognize that this is a former impoundment or where a dam was. And that's really the goal, to mimic and allow nature to take control and form the site as it sees fit. So that gets us to the last phase of the project. So once construction's wrapped up here, we will be conducting monitoring for several years post project. That monitoring is going to include site survey work to ensure that the slopes and channel dimensions are appropriate and as designed, and follow-up surveys to ensure that everything is sort of going as expected with the channel formation. We'll also be doing sediment monitoring downstream of the site to make sure that, as we expect, there won't be any negative impacts of the project from a sediment standpoint in any of the sensitive areas downstream. So just to recap everything, DER got involved in this project in 2018, and we've been in the design and permitting project with project permitting phases with TNC for the last 6 years. We're very excited to now be entering the implementation phase. That should take approximately 3 months. There will be a break sort of around January while we wait for things to thaw out, and then a smaller deployment in the spring to do some of those plantings that just doesn't make sense to do in January. And then for the next several years, we'll be monitoring this site closely to make sure that everything that was expected and planned is what's happening out there, and that no further intervention is needed. And with that, I will turn it over back to Karen.
Thank you so much, Chris. I love seeing the before and after pictures because it's so dramatic. So now we're going to answer a few questions and open it up to you. So I see some questions are coming in. So why don't we start with one question. Chris, there are fish living in the pond right now. If the dam is removed, will they be harmed? What happens to them?
Yeah, that's a great question, and one that comes up often. So the fish that live there now, well, I should say the pond is going to be drawn down slowly. So it's not like what you might have seen on TV where, a stick of dynamite goes off and the dam explodes and all the water flies out. The water is going to be drawn down slowly over the course of a day or two, which really allows fish to move on out of the area. If they're unable to or get stranded, I will be out there. There will be folks from Mass Fish and Wildlife out there as well, to help any fish that are stranded or sort of trapped within the impoundment. Fish usually are pretty good at getting out of the way. It's really things that are less mobile, like freshwater mussels, um, or other things of that nature that really need a lot of assistance. So we'll be scanning the impoundment as it's being drawn down, and relocating any stranded animals that we see. And the fish will be able to move upstream and downstream freely once the dam's out, and they'll be able to find suitable habitat elsewhere.
Yeah, thanks. And did want to add that the DFW has done some sampling in the system, and the brook trout population there is as large as any other, cold water stream in the state. So we were very pleased to hear that. It's a great site for that species that really needs the cool streams that Chris was talking about.
Yeah, hundreds. I was out with them last summer, hundreds and hundreds. It was incredible to see.
Yeah. I see a question about access. So where will the trail exits be onto East Street, and how will we be promoting signage and parking? So the start of the trail will be about a mile north of the border. There's a pullout there already, and for those of you who know Mount Washington, there is an empty kiosk. So we are going to be working on signage for the start of the trail, and that's where the parking will be. When you walk on the trail, you'll go into the forest a while, you'll come eventually to the old dam site, and then you'll come back up to East Street, where there won't be any parking because we don't have we don't have the ability to put a parking place there, and you'll just walk back up East Street, or you could just walk back the way you came on the trail. So let's see that. Let's see about public access during the project. I think I can answer that one too. I think during the actual construction project, public would not be allowed in the active area, but the preserve itself is not closed. It's 1,500 acres. It's open for hunting and things like that. So you won't be able to go in that particular place, but it's a large place. So
And there will be signage, right, Karen, letting
yeah.
people know.
Yeah, there'll be signage. Exactly. And we don't expect any impacts to the Appalachian Trail crossing, which is quite a ways down the brook. And so we probably won't, we wouldn't even have signage down there. So then there's another question about someone who lives on East Street. There's a lot of stilt grass, which is an invasive plant on East Street. What are we doing to avoid the infestation? We do a few things. We have an invasive management plan that we were required to do as part of the permitting for the project. And we have been controlling stilt grass, any stilt grass we see. There's nothing down by the dam. The stilt grass is mostly on East Street, but the vehicles are required to be washed before they access the property. And then we will be controlling, looking for stilt grass after the project is done, and also controlling it as well. Let's see. Oh, here's a question, Chris, for you. Let's see. There's been a lot of discussion about construction. What about the prep work, assuming there's engineering and ecological planning?
Yes, so as I mentioned, there was about 6 years of planning and permitting and design and discussion that went into developing this project. From an ecological side, we did quite a few surveys to look at what the aquatic community looked like upstream, downstream. There, we used reference reaches upstream and downstream to guide the design for things like channel dimensions, slope, width, things of that nature. And a lot of thought has gone into sort of how the channel is going to be constructed, as well as how the floodplain is going to be enhanced, really with ecology guiding that whole process. There are also other sort of stakeholder concerns, such as the sediment downstream that was taken into account and helped guide the process and design of the project as well. So yeah, a lot of thought, a lot of time went into planning this project.
Yeah, we have to get a large number of permits to do
Yep.
this work. Here's another one. How are we going to manage all the, how will you manage all the material removal from the dams? What do we do with the sediment and concrete?
Yep. So the concrete will be disposed of sort of as construction debris at a facility that accepts that kind of material. Most concrete in Massachusetts is recycled. I anticipate this will likely be recycled as well. Um, Things like rebar obviously can't go to that facility, but will go to, the appropriate place. And we're going to try to reuse as much of that soil on site. The material is unsurprisingly clean. There aren't really chemical contaminants that were found in the impoundment. Um, so we're going to use some of it on site to fill a historic burrow pit that was likely where the material that now makes up the dam was excavated from. So we'll be, filling that in, um, as well as using it for grading and other purposes on site. But any sediment that's not able to be reused on site will be trucked off site to a receiving facility.
Okay. Here's another question about the time frame for determining how it's impacted the fish population. I can answer this one. I know that DFW is planning to survey probably the fish again after, so probably next summer there will be another survey. I think they've done a couple surveys pre-removal, so they'll do that again.
Yeah, we've done at least two, maybe three surveys in the past 4 years, pre, and then we'll be doing probably two or three surveys post as well. Um, and what we see at other sites is that, especially trout recolonize these areas very quickly within months. And then within years, the communities really look almost identical upstream, downstream, and in the former impoundment. And not just for fish, but also macroinvertebrates.
Do you expect what other fish species would we expect to see besides brook trout that might use the area?
Um, well, it's funny. What you would expect to see is, things like dace, slimy sculpin, but the past couple surveys, all we found is brook trout. Nothing but brook trout, which is a little bit weird, but not completely unheard of. Um, but yeah, it's maybe a little creepy Halloween vibes that, we have cannibal fish there, but it is an entirely brook trout system, at least immediately upstream and downstream of the dam.
How how long do you find, since you've seen many dam removals in Massachusetts at this point, how long do they usually take?
For construction or just the whole from an idea to completion?
Well, the question wasn't that specific, but so yeah, you
Yeah.
could.
So construction's usually several months.
Mhm.
Simple projects, it could be, a month, 2 months. Really more complex projects could be 6 months to a year. Um, but the planning and permitting is usually um, 3 to 5 years. 3 years is like everything goes perfect. Um, 5 years is more typical. And then in your extreme cases, we have projects that have been in the works for 20 plus years and beyond. So it's really, there's a wide variety. Um, and it really depends on how complex the project is.
Okay. Yeah, the permitting and takes much longer than the actual removal.
Yes. Yeah, the
Good
removal of the
design.
dam itself is like a
Yeah,
day.
yeah. Um, what about, we have a question about flooding risk without the dam, or are we expecting the risks to improve without the dam?
So this is a what's called a run of river structure, and the way I like to think about it is imagine a full bathtub with the faucet running. Um, the amount of water that's running into that tub is exactly equal to the amount of water that's running out of the tub. It's not creating flood storage in any way. It's not slowing the flow of water in any way. Water is just simply flowing into it and over it, and that's it. So removing the dam really doesn't change flood conditions at all downstream. Not, anything noticeable. And then upstream, um, there's going to be new flood storage available in the floodplains that were, permanently flooded by the dam previously. So there's a slight improvement with flood storage upstream. Um, really no change in flooding. We don't anticipate change. And that sort of goes back to the previous question about sort of the engineering that went into this. There was a lot of what's called hydrology and hydraulic modeling that went into it, which really is just understanding how the behavior of water is going to change when the dam is removed. Um, and so we looked at that. That was one of the many things that we looked at. Is this going to cause flooding issues anywhere else? And really, the modeling came back as, no change downstream, which is pretty common for run-of-river structures. Very few dams actually provide flood storage.
We have a question about how any monitoring about the bird population. We don't have any plans to monitor the bird populations. It's a very small pond. And I think any sort of waterfowl are pretty mobile, and there's Plantain Pond is not far away. So I expect that those particular species are very mobile, and then other species like forest species just move through the system and move around. So we don't expect any major impacts to the bird populations. I don't know, Chris, you have seen anything anywhere else? Want to comment?
Yeah, no, I agree with everything you said. Birds fly and they can go
Yeah.
large distances with ease. They'll find another pond if that's what they're looking for. There's over 3,000 dams in Massachusetts. There's plenty more ponds for them, not running out of that habitat.
Um, so we kind of were out of questions. So maybe we'll move towards wrapping up. I wanted to ask Chris if you have any final thoughts you'd like to share about the project.
Yeah, just say, this is a really exciting project that DER is proud to be a part of and to support. It's going to result in safer recreational opportunities for the users of this area and a healthier ecosystem as a whole. I also want to give a shout out to Interfluve, the engineers who developed a great design at this site and have worked with us throughout the process, and Sumco Eco Contracting, who is one of the premier restoration contracting firms out there, who will be carrying out the construction work. And just wrap up with a thank you to the Nature Conservancy for doing the right thing here and leading this restoration effort.
Thank you, Chris. And I want to just give a shout out again to all the support that DER has provided, both technically and financially. And while I mentioned the Mass Environmental Trust, we had a couple anonymous foundations that provided key funding for this project, enabled us to move forward. So I think everybody, thank you everybody for joining us today, and thank you for your support of TNC. We will be sending everyone a follow-up email over the coming days with a link to the recording of the webinar that you should feel free to share with others who might be interested in the project. And we'll hope to have some articles as well coming out about the project. as we get started. So I hope everyone has a good night, and thanks again for joining us.